So moving on from area, we're going to look at volume for a few minutes. We saw that area in the past was defined as the amount of space in a two-dimensional object. Now we're going to see that volume is the amount of space within a three-dimensional object. And then in addition to that, we have another definition here of capacity. Now capacity is the amount of fluid that fits in a three-dimensional object. Not a whole lot different there between the two. But one just gives you the breakdown of the dimensions of the object. The other one gives you an actual a measure of something filling the object. Okay, so anyway, we've got some units and conversions to kind of sort through with both of these different definitions. So volume, we measure it based upon our lengths, right? Our cubic lengths, right? Inches, feet, yards. So you got cubic inches, or if everything is measured in inches, so it's relatively small object like your cereal box sort of object. Cubic feet, you might be looking at something like a bathtub, right? A little bit bigger object, or a fish tank, an aquarium sort of thing. Cubic yards, maybe you're looking at something more like a swimming pool. Okay, and so you can kind of figure out, based upon the size, what's more useful, what's more applicable. However, in terms of capacity, when you're just filling these objects up, we have lots of different breakdowns. We have from very small, something called ounces, to cups, which is like a cup, right? Like a cup of coffee, a pint, a quart, and a gallon. You guys probably know what a gallon of milk looks like, and that's one of your bigger capacities. So you got a gallon of milk, you got your quarts, your pints, cups, ounces, kind of going in reverse. So now how do these conversions work out? Well, if we look at just the conversions of volume, we know that there are 12 inches in a foot, right? Well, to go to cubic feet, you cube both sides. What's 12 cubed? 1728. Okay, so there's 1728 cubic inches within a cubic foot. So if you took a foot by a foot by a foot, there'd be 1,728 little teeny cubes that are 1 inch by 1 inch by 1 inch by 1 inch inside of that. Okay, cubic yard. If you took a cubic yard, that'd be this by this by this roughly. There's going to be 27 cubic feet. That's 3 cubed, right? 3 feet by 3 feet by 3 feet. 3 times 3 times 3 is 27. All right. So that's how we get those conversions. Those are pretty basic. You're just cubing the 12 and cubing the 3. Now the conversions between cups, ounces, gallons, quarts, and pints are a little bit, you kind of have to know these. But basically you have 8 ounces in a cup. So if you have an 8 ounce cup, right, you kind of correspond those to an 8 ounce cup of coffee, right? So a cup is 8 ounces. Very common, phrase, I guess. So 8 ounces are in a cup, and there are 16 cups in a gallon. That's one that not a lot of people realize. So in a gallon of milk, you got 16 cups of coffee. I wouldn't put coffee in my milk. Maybe milk in my coffee. No, I don't know. I like my coffee black. But anyway, 16 cups in a gallon. You also have 4 quarts in a gallon. It's called a quart, QT, because it's a quarter of a gallon, right? Makes 4 of them makes up a gallon. And then a pint, there's 2 pints in a quart, all right? So you take a quart, cut it in half, you get a pint. So pints are smaller than quarts. That's why something called pint size is usually small, right? So anyway, it's smaller than a quart. 2 pints make up a quart. So anyway, these conversions are kind of nice. They're all powers of 2, which I really like, right? This is 2 to the 1, 2 squared, 2 cubed, 2 to the 4th. So that helps me to remember those, that each of those conversions is a power of 2. So then you can convert between cubic units and these capacities, so volume to capacity conversions. If you wanted a cubic yard, right, one of these cubic yards, and I can just about reach, all three dimensions standing here. It's 200 gallons. I could put 200, oh, that's interesting. I never really considered that. So just in my reach, and my reach is actually closer to 2 yards, almost 6 feet. So that's more like this. This, by this, by this. You can get 200 gallons of milk in there. Crazy. Feels like it wouldn't be that much, but it is. One cubic foot, that's about this, by this, by this, is going to contain, really? 7.48 gallons? Why does that feel like that's too big of a number? Cubic foot, 1 by 1 by 1 cube is going to, or I don't know, I guess it will work. That's what we're going with. It just feels like that's too big of a number to me. It feels like there'd be like 2 gallons in that, but I guess it's almost 7.5. And then 1 gallon gives you 231 cubic inches. So another conversion. If you had a gallon of milk, you get 231 cubic inches inside of that gallon of milk. Okay. Anyway, some of those are kind of striking me as not intuitive, not what I would have thought, but that's what we're going with as our conversion. So anyway, so you can make these conversions. Let's take, for example, a swimming pool, right? If you've got a swimming pool that roughly, not a swimming pool, I don't want a swimming pool. We could do a swimming pool. I wasn't going to do a swimming pool. You could do a swimming pool. Let's do a swimming pool. No, why? What am I doing? What am I mumbling here? Let's go with a swimming pool. You guys are all laughing at me now. Let's go with a swimming pool that is maybe a rectangle in size. And you have, some sort of let's do a rectangular solid swimming pool. Now most swimming pools are round on the ends, but maybe this is one of your like swimming pools in a high school sort of thing. And it's all the same depth. So I don't have like a deep end or a shallow end. It's just all one big rectangular solid. In the swimming pool, just to give some reasonable dimensions, I don't know. And I'm not going to make it a huge like lap pool or something. We'll just make it a little bit smaller. So let's do like 50 feet across, or 50 feet in length. Let's go maybe 30 feet across here and maybe 10 feet deep. So we've got some nice round numbers anyway to work with. So we can find the volume and we can find the capacity of this swimming pool. Okay, so the volume, the volume is the product of the three values, right? The height times length times width. 50 times 30, if I just keep the zeros off for a minute, 5 times 3 times 1 is 15, and I need 1, 2, 3 zeros when I multiply those. So that's 15000. That's 15,000 cubic feet in that swimming pool. Okay, so the swimming pool is found just by looking at the product of the dimensions. However, the capacity of the swimming pool, that means how much water you could put in there, then you're going to try to convert the cubic feet to gallons, right? Cubic feet to gallons. If 1 cubic foot is 7.48 gallons, then, so for capacity, we're going to do a dimensional analysis problem. 15,000 cubic feet over 1 times, now I want gallons on top, cubic feet on the bottom to cancel, so it's 7.48 gallons in 1 cubic foot. So I'm going to do the multiplication on this one. 15,000 times 7.48, 112,200 gallons. So that is 112,200 gallons of water can fit if that swimming pool is filled to the top. That's how many gallons can be in that swimming pool. Okay, so kind of neat. And then we can do something similar if we wanted to go with, quarts. You just multiply that by 4 and you get a number of quarts in the, that's ridiculous. That's a lot of quarts. And we could do this with a bathtub or an aquarium or any number of things, right? So just kind of an interesting conversion and more dimensional analysis, right, coming through.